So let's start off with some easy stuff. What's your name and your major?
Okay, my name is Caitlin Chasmar. I'm currently a senior majoring in supply chain management with a minor in economics.
All right. So today's interview will be about electricity and magnets. So I'm going to start out by asking some questions and then we'll go through some demos. So the first thing I want to ask is, what are magnets? Like, how do they work?
Okay, so magnets are basically atoms made up of a positive and a negative side. So the negative side is electrons, and then the positive side is either protons or neutrons, and the negative side of magnets attracts to the positive side of other magnets.
Okay. So you said that magnet opposite poles attract to each other. Do they attract to anything else?
Well, a positive side does not attract to another positive, and same as a negative does not attract to another negative. So only positive and negatives attract to each other, and they attract to materials that are magnetic, like metals.
Like, what types of metals are magnetic?
I think maybe iron might be magnetic, or silver, maybe different things. Like a magnet will attract to your fridge because of the magnetic connection.
Are there any particular properties that make them magnetic that you can think of, or?
I know magnets are metals that are magnetic, I think, are more malleable, but I don't know other properties.
Okay. So if I took something that isn't attracted to magnets, say like plastic, right? Or not necessarily plastic, but something that isn't attracted to magnets, and I put it close to a magnet, would there be any effect?
No, there wouldn't. Only magnets affect other magnets.
So I'm going to show you a little bit of a demo. It's a video demo. We only have to watch about a half a minute to a minute. So here, it's a copper pipe and a neodymium magnet, right?
Okay.
So pay attention to what happens when he drops the magnet near the copper, and also when he drops it inside the copper.
Okay, it's 2 inches. Oh wow, it got a charge. It's like when you take a balloon and you rub it on your hair, and then suddenly your head has a magnetic, suddenly you have a charge. That's what it looks like, what happened. It's almost like every time it goes through, it's really slow.
Right.
Okay.
That'll be sufficient. So what did you observe in the demo? What was happening? Describe like the entire setup of the demo and any observations you have.
Okay. The silver metal was what?
That's a magnet.
Okay, so the magnet was basically rubbed up against the iron.
It's also a copper pipe.
It was against the copper. And when you rub it up against the copper, initially it didn't do anything, especially when it was on the outside. But I think that when the magnet rubbed up against the copper, it gave it a charge, kind of like when you take a balloon and you rub it on your hair, and then suddenly your hair sticks up because you have a charge. And so because of that, when you put the magnet through the copper pipe, it had a charge, which made it fall through much slower. Gravity was still pulling on it greater than the charge of the electron, so that's why it was still able to fall. But that now there was suddenly a connection, maybe between because if a magnet left a charge on the outside that was, say, positive, and then now it has a negative charge going on the inside, it's going to move through slower because it's trying to attract to the outside, but it's not directly connected to it because there's the copper barrier.
Right, okay. So when it was dropped on the outside, what happened?
So when it was dropped on the outside, I think, because copper is a metal.
Right.
I don't think it is a particularly magnetic one because pennies are made of copper.
Yeah.
but I think that because maybe it's a metal, it was still able to almost like pick up some of maybe the electrons that the magnet had. Like it was able to take some of the electrons away from the magnet, and then it kept it on the copper pipe, so that when you put the magnet through, the electrons were trying to go back to the magnet, but it couldn't because it had a barrier between it.
And if there wasn't a barrier, what would happen?
If there wasn't a barrier of copper, the electrons would have attached back onto the original magnet.
So yeah, that's kind of the part about magnets. Now I'm going to ask you some questions about electricity and electric fields.
Okay.
So, what do you know about electricity?
Oh dear, that's so general.
That's a very general question, and you know, answer however you think.
Okay, electricity, what's fundamental for our society.
Okay.
I took physics junior year of high school, so I remember learning about electricity, and that there was different pipes that almost it could go through, like that you'd have different areas that electricity could travel through. Electricity travels through wires to bring it into your house across different buildings, and it's the movement of, I believe, photons, probably because it's light, so that's why I'm thinking that it's maybe photons, and that they travel through wires and pipes. Yes, that's my answer.
So what causes them to travel through wires?
Oh, maybe magnets. I don't know. Because basically you have a switch, and something that you do when you turn on a switch or off a switch is creating that movement. So I'm thinking that when you turn the switch on, you're either releasing the light that wanted to come through, or you're attracting the light to the place that you wanted.
So what do you know about electric fields?
So I know that there's electric fields in different areas. I think there's electric fields almost around the world, like surrounding the globe, and then also different electric fields in different areas of the world. I don't know that much about them.
That's fair. So talking about electricity, do you know what an electromagnet is?
I could take a guess. I think
Okay.
what an electromagnet is that, as I was saying, so the light wants to travel. The light is going to travel through a wire, and when you turn it on, an electromagnet is what attracts the light from the source of the light to where you want to bring it, such as a lamp or lantern.
Okay. And kind of how does that function? Like in terms of, I think you gave an answer for this earlier, but like, how does an electromagnet function?
So it has a positive side and a negative side, and the light is attracted probably to one of the sides. And so what I'm guessing is that when you turn a switch on, or when you turn a device on, you're maybe switching what side is facing the light, so then it can be attracted to the place that you want the light to turn on.
Okay. So we're actually going to do a second demo now.
Okay.
So this demo kind of involves this like little coil of wire around a screwdriver, right?
Okay.
And a little segment of metal wire that I have here, right? And also a 9-volt battery. So what do you think will happen when I touch the coil of wire, or this screwdriver with the coil of wire to this?
Nothing, because there's no battery.
Right, so nothing happens, right? I mean, they're just pieces of metal.
Mm-hmm.
So if I attach a battery, what do you think will happen?
Maybe, is that a light?
No, this is a screwdriver handle.
I don't think anything's going to happen. I think it's going to need the wire.
Okay. Oh, I mean if I attach the battery and then attach it, I touch the wire?
It's going to create
Alright. So let's see what happens. So when I attach the battery, right, this is a little finicky, but
Oh, it creates a magnet.
so what happens? What do you think will happen when I release the battery?
It's gonna fall. The wire's gonna
Well, I don't think it necessarily falls, but if we try to pick it back up,
It's not gonna be there anymore.
right? No, that's just my gravity onto it. So what do you observe when, like, what did we just do? What happened?
We created a magnet.
All right. So what do you think? Well, why is there a magnet that's now created?
Because a battery has a positive side and a negative. Oh, so a battery, I believe one of these is positive and one of these is negative.
Okay.
And when you put the two wires through, you created a circuit.
Right.
And
Okay.
by creating a circuit, you're able to create a magnet because you had a flow of positive and negative.
Okay. So and when we disconnected the battery, what happens?
You cut off the circuit. You cut off the power of the circuit.
Right. So what happened when we did that?
So when you cut off the power of the circuit, you cut off the magnetism. It wasn't magnetic anymore.
So so when we run electricity through this type of circuit, it creates a magnet?
A temporary magnet, I believe. Yeah, it creates a temporary magnet, but it's reliant on the fact that one of the wires is touching the positive side of the battery, one of the wires is touching the negative side of the battery, and that they are connected at all times. And whenever you remove one of those factors, it gets rid of the magnetism.
Okay. So let's kind of like talk about what we've gone over today. Like what did we discuss and what did we observe from the demos?
Okay. So we talked about electricity and we talked about magnets. So in the magnets, which is why they both connect to electromagnetism, because originally we had the demo with the copper and the magnet, and we found that when you rubbed the magnet onto the outside of the copper, you were leaving, say, electrons on one side, and then putting the magnet through the copper, you had a magnet that was still attracted to the outside of the copper, but the gravity was weighing on it more than the force of the magnet. And we found from this demo that if you use a battery, you can have a circuit of magnetism. So batteries can be used for magnetism. So that's how electromagnetism works, because that means that electricity probably works that you almost have a battery, and that when you put the on and off switch, you're creating a circuit, and when you turn the switch off in your house, you're disconnecting the circuit, and then suddenly it's not magnetic anymore.
So how does what you've observed today compare to any prior knowledge? Like, was there anything that was unexpected or?
Well, I definitely do not know how electricity works. I think I understand that there's light in my house, but I never bothered to question where it comes from. I just accepted that it was there. And I definitely did not think that it had anything to do with magnets. I thought that there was some sort of flow of electricity, or I did not know where it was coming from, but it's powered by magnets, and I never realized that.
In terms of the demos, what took you the most by surprise?
I did not think that this was going to be magnetic. In my mind, I thought it was gonna make a spark when you were putting the battery with the coil, because I thought it was gonna be a flow of electricity, not a flow of magnetism. So I was really shocked that the wire was attracted to the circuit.
Right.
That took me by surprise. I completely did not expect that. But it's really surprising. It's cool.
Well, thank you so much for having this interview with me.
Of course, thank you, Sam. It was good.